Today we're going to analyze graphs of polynomial functions. You're going to use intercepts to graph polynomial functions today, as well as what we learned about in behavior last time. So if we have our polynomial function written in standard form, okay, so we start off with a n x to the n, so our leading term, our highest degree of x, and we go on down to what they're calling a0, which is the constant. Then what we mean by a zero is k, or we're going to refer to zeros as k. K is a zero of the polynomial function f. Then x minus k is a factor of the polynomial function. And k is a solution to the polynomial function. And k is an x-intercept of the graph. So there's this relationship. Basically what this is saying is if a number is a zero, in other words, if we plug it into the function, if it's an x value that we plug into the function and generates an output, a y value of 0, then x minus that number is a factor. We consider that value, that number, to be a solution to the polynomial function when we set it equal to 0, and it is the x value of an x-intercept. Okay, so we're going to graph the function f of x equals 1/6 times x plus 3 times x minus 2 squared. So the first thing we're going to do is plot the intercepts. So we've got, remember, it's x minus k, so this would be x minus -3, and then x minus 2. So -3 and 2 are zeros, so we're going to plot -3, 0, and 2, 0. And then we're going to pick some points between -3 and 2, and then some beyond that, some that fall that are smaller than -3 and larger than 2. And so we've got some here between the two values, and then one that's larger. So we're plugging in -2. Remember, we just plug it in right here and we evaluate, and we get 8/3. If we plug in -1 and we evaluate, we're going to get 3. If we plug in 0, we're going to get 2. If we plug in 1, we get 2/3. When we plug in 3, we get 1. So in addition to this, we want to think about the end behavior, and then we're going to use all this together to do a nice graph of the polynomial function. All right, so let's look at what the end behavior is going to be. Okay, so 1/6 is positive, so that means it's going to go up to the right for sure. It'll either go up to the left if we have an even degree, or it'll go down to the left. So let's see, we've got one factor here of x, and we have two factors with x in it here. We've got x times x squared, essentially, when we're thinking about degree. And so we've got, or if you want to think about it, we've got 1, 2, 3 factors, because the x minus 2 is squared, means x minus 2 times x minus 2. And so we have a cubic function. It's going to be the third degree. So it's going to go up to the right because of that positive coefficient, and it'll go down to the left because for odd degreed functions we have opposites. Okay, and so here we've got the -3, we've got some of the other points that we found, and then the 3, 1, and then we used the fact that, oh, yep, this is going to continue to go down to the left, it's going to continue to go up to the right, and we've got a pretty good graph of our polynomial function. If you're a little confused on, well, how did we get these y values? Remember, you're taking the x values, you're plugging them in, and you're simplifying. So let's go back and look at 0. So if we do 0 plus 3, we get 3. And then 0 minus 2, that's going to give us -2 squared. So that would be 4 times 3 is 12. 12 over 6 is 2. Okay, and once you've done your problem to try on your own, you'll come into class. We'll work through that together, and we will review again how to create tables like that. Okay, one thing that can be helpful too is realizing how many turning points you're supposed to have. If you have a degree of n, then you're going to have at most n minus 1 turning points. And so what we're going to do here on problems like this is we're going to identify the x-intercepts and where the local maximums and minimums occur. Right here, it might be helpful to notice, okay, this is x to the third, so the highest number of solutions would be, turning points would be 2. Because there's n minus 1 turning points at most, so 3 minus 1 is 2. So we're going to use a graphing calculator to graph this. So go ahead and enter x cubed minus 3x squared plus 6 into your graphing calculator. And you can see that we can find the maximums and minimums, and we'll go over that in class. And you can also find your x-intercepts with the graphing calculator. And so if we find a 0 or x-intercept here, we find that it is at negative 1.20, and it has a local maximum at 0.6. See how it looks like the top of a mountain right there? That means it's a maximum, and a local minimum at 2.2. Now the maximum itself is the function value 6. It occurs at 0, and the minimum, the local minimum, is 2 because the y value is at 2. It happens to occur at an x value of 2 as well. All right, for g of x equals 5x to the fourth minus 6x cubed plus 3x squared plus 10x minus 3. You want to go ahead and put that in your calculator. Things to notice, there can be at most 3 turning points because n minus 1 is 3. We know the n behavior, both ends are going to go up because we have an even degree, so they're going to go the same direction, and we have a positive leading coefficient. So let's look at what it looks like. All right, here is a picture of our function, kind of interesting here. It's got 1, 2, 3 turning points. 2 are local minimums. 1 is a local maximum. We have that in behavior we expected. Let's see, it crosses the x-axis 1, 2, 3, 4 times, and so we would need to find 4 zeros. And so we get that the x-intercepts are at negative 1.140, 0.290, 1.820, and 5.030. And then the maximums is here at 1.1, 1.11, 5.11, and there's 2 local minimums, one at negative 0.57, negative 6.51, and 3.96, negative 43.04. So if you can't see a good picture of your graph when you first put it into your graphing calculator, remember you can zoom out, zoom out, zoom out until you see the complete picture of what's going on. Okay, if you can see the ends, you want to be able to see all the wiggles in the middle. Okay, so you want to make sure you can see all of that. We will go over, especially right now because the school is kind of transitioning from CAS calculators to 84s. We will go over how to use the calculators that you have in class to find these important pieces of information. Okay, so go ahead and try the problem to try on your own. We'll go over those in class, and I'll answer any other questions that you have. That's it. Thank you. Have a good day. I will see you in class.